Hello and welcome to the second video in this series following along the development of Socks, a simple walking game. In this video we're gonna essentially build this application here where these eggs are being retrieved from the backend service that we wrote in the last video. So we're gonna create an HTTP client, and we're also going to make use of future builders and list views in the UI. So to start, we'll create the Flutter application itself. Creating a Flutter app is even easier than creating a Spring Boot app. It's as simple as running Flutter create and then the name of your project. For example, in our case, Flutter create and then socks app. If you don't have the Flutter tools installed, just Google Flutter followed by install and follow the instructions on the first page. So now we see that the Flutter tool has created our application, which we can now open in Android Studio. Alternatively, you can use VS Code and other IDEs. Here's the app opened up in Android Studio, and as we can see, a new Flutter app is initialized with a simple counter app, which I've got running at the moment as a Windows application by just selecting Windows in this drop down and pressing the play button. You can also start it as an Android app in the emulator or on a device that you have attached to your computer, but it's kind of for debugging and everything, it's just easier to have it running as a desktop application. So at the moment, the initial application, this counter thing, is a simple button with a counter that increments when the button's pressed. So we don't really want any of that. So I'm just going to essentially tear out the initial application and add in and replace it with just a list of eggs essentially for now. So I've gutted out the initial app and created a skeleton of the eggs page. So here you can see we've got a list of the eggs with their progress. At the moment, just driven from this list here. So it's just sort of dummy data that at some point we'll get from the back end. And likewise, we've got this walk button that at the moment doesn't do anything, and I've just got a to-do here of call the walk function on the back end. So the list view itself is just simply taking the list of eggs and mapping them to list tiles, where the leading widget is just an egg emoji essentially, and the title is just some text of the current progress, i.e. the distance walked over the total distance. So in the last video, we created our backend and added two endpoints, the /eggs endpoint, which just returns a list of eggs, and the walk endpoint, which just walks the eggs, which just simulates a 1.5K walk and returns an event. So the client that we're going to create will make these requests to these endpoints, as well as essentially interpret the responses that it gets back. So we'll need to create an egg object for our client to parse this response to, and we'll also want to create an egg event type that our client will parse this result to. So the responses from the server are in JSON format, and what we want to do is parse them to Dart objects, and the way of doing that in Dart/Flutter is to make use of the JSON serializable package, which we can add to our project by running dart pub add and then JSON serializable. And we'll also need the build runner package as well to make use of the JSON serializable package. So with those two installed, we should be able to see in our pub spec that they have been added as dependencies. So we've got the JSON serializable here and the build runner here. With the required packages installed, let's create the Dart classes for the JSON objects in the response. And to remind ourselves of what the eggs response looks like, let's just curl the eggs endpoint. And we see that each of the individual eggs have an ID, a distance walked, a distance total, and an item that may be null. We're only going to be working with a handful of objects, so we can just keep them all in a single Dart file, which we'll create under the client package. And inside this model Dart file, we'll create a class called egg. And that will have all of the fields from our response, so an ID, distance walked, and so on. The ID is just a string. These two are just doubles, and the item is a nullable string. And if we, with Alt Enter, we can just create a constructor that takes all of those fields. As well as the egg object, we'll also want a Dart object for the response from a walk call, and the walk call is just simply this event, so we call it egg event, and it's got this enum type which is either walked or hatched. So our event type enum would just be an enum with walked and hatched, and our egg event will sort of tie these two classes together essentially. So it's got called egg event and it's got a type and an egg. Cool. So to actually make use of the JSON serializable package, we need to annotate all of our classes with JSON serializable. So we'll annotate our egg and our egg event class. And we just add an import statement to the top. The JSON serializable package works by generating functions that convert JSON to our objects and vice versa. The code generation will put these functions in a file of the same name as the file that we've got our classes in, but with G for generated before the Dart extension. And we need to include this in our file using the part directive. So if we just type part and then model G Dart. So currently this file doesn't exist, but if we run the code generation itself using this pub, Flutter pub run build runner build, it will generate the class for us and sort out this current error. If we just refresh this, we should see a class has been generated, a file has been generated with methods such as from JSON for the egg and to JSON for the egg, and likewise to and from JSON for the egg event. The thing that it's complaining about here is we don't have this from JSON method on our egg class. And what we need to do to fix that is actually add these factory methods that make use of these functions. So we're using our from egg from JSON in this factory method. And likewise, we're using the toJSON in this toJSON method. And we'll add the same thing to our event class here. One small change we want to make as well is the response from the server. All the enums are all uppercase, and we just want to be able to handle that here. I'm sure there may well be a nicer way, maybe, of making the deserialization case insensitive, but for the moment we can just do this, so it will just find the uppercase and associate it with walk, or map it to walked. And just to get that working, we need to run the build runner again. And now in our generated file, it's using the uppercase words instead of lowercase. So with the response classes in place and all serializable or deserializable, we can start creating the client itself, which will interact with the backend. And to make HTTP requests in Flutter Dart, we'll need to install the HTTP package, which you can just do in the command line like so. And what this does is provide like HTTP client and other functionality to actually make HTTP requests. So let's add a new Dart file called clients to contain our socks client. And what our socks client will need is a URL, so the URL of the API, and also a client which is just from the HTTP package, and it's got methods like get and post to do get and post HTTP requests. So we'll add our constructor and we'll make it so that by default you don't actually need to provide a HTTP client. So we'll make this optional essentially, and when it's not provided, we'll just default to a new client. So next we'll start adding our get eggs method, and that will return a future containing a list of eggs. The reason it returns a future is because HTTP requests are asynchronous, i.e. they're not going to immediately return the list of results. There's like a load of processing going on before they return. And that's what a future represents, i.e. it's saying in the future it will return a result or possibly an error. So what our get eggs method is going to do is simply make a get request to the eggs endpoint. So we'll set up the URL, which is just whatever we've provided as our API URL followed by eggs, and then make the request itself using our HTTP client. So HTTP get the URL that we've got there, and this await function, which just means await the response of this get operation. And we can check the status code of the response. So if it's not 200, then some error happened and we can just throw an exception. So 200 just means success in sort of HTTP status code world. Next, we want to parse the response. So we can use this JSON decode to convert the body into a list of dynamic, and then use the from JSON method that we used earlier, that we created earlier, to parse each of the individual eggs, and then finally just return the response as a list. So that's our complete eggs function. Now we can go and replace the hard-coded data that's being used to populate this list here and replace that data with a call to the backend. And to do that, we're going to make use of a future builder, which is a widget that essentially helps us manage a future and update the UI as the state of the future changes. So once it's loaded, we'll actually display the list, but while it's not loading, we'll maybe just display a bit of text that says loading. So to start, let's add the client that we've created to our stateless widget, our eggs page there, and import that. So we'll wrap our list view in a future builder just by, unfortunately there isn't a wrap in future builder, but there is just a simple wrap in builder. So we'll go for that and then just rename this to future builder. So the future builder requires the type of the future, i.e. the type of the result of the future to be passed in as its generic parameter, which in this case is just a list of eggs. And second, it requires the future itself, unsurprisingly, which we'll just get from calling client.getEggs. And what this builder method does here is it'll be called every time the future changes. So, and it will pass in a snapshot, which is just either the data that the future is going to return, i.e. the list of eggs, or some information about it being in progress. And all we need to do in this builder is just decide whether we want to show the list or show a text widget saying loading. And to do that, we just we'll just return a text widget with the text being just loading. So if we make it past this, we get to the point where it does have data, and we can just pull out the eggs by getting them from the data of the snapshot. And at this point, we can just put an exclamation mark because we know that it's not null. And the final thing we need to do is just make use of our egg. So we'll print out the distance walked. We will, that needs to be eggs, and we'll delete this up here. And we'll just continue writing our sort of progress indicator essentially. So now we see that it's made the request to the backend and retrieved the 2 eggs. Just to confirm, if we make the call to the eggs endpoint, we see that we've got a 3 and a 0, and both of them are over 10, and there are only 2 eggs as well. Currently, the future builder is only actually called once when the application loads. So even if these eggs change, like behind the scenes we do a call to the walk endpoint, we won't actually see the changes reflected in this list until we restart the application, which for now we'll not worry about this, as in the next video we'll introduce some state management. So we'll essentially separate the manipulation of the state, i.e. triggering any changes to this, from the widget that displays the data using the block pattern. The last thing I'd like to do is add some tests for the client that we've created. So to do this, we'll need a way of mocking this client that we provide in, this HTTP client. And luckily, there's a really nice package for mocking classes called Mockito, which we can install on the command line just by adding the Mockito package. To demonstrate what Mockito can do, I'll create a test for our client. And annotate that class with the generate mocks method, passing in a list of the classes that we want to mock. In this case, it's just the client class. And now if we run our build runner, what Mockito will do is build a mock version of this client. So you see Mockito has created this client test mocks file, and that contains a mock client that implements the client, and we can use that in our class. So if we instantiate one, then we can use the when function that's provided by Mockito to essentially force, for example, a call to get, which is the HTTP get function. We can force that to return a particular result. So in this case, any call to a get to any call, a get to any URL will return, let's just say, a response that has a body of hello and a status code of 200 for success. Then, whoops. I just need a async. Then we can call our client and just pass in some URI. Just don't know, bbc.co.uk, whatever. Then if we just to see what's going on, if we just print the response body and the response status code and then run this test, we see the mocked response in the console. So you can probably see what we're gonna do. We're first gonna create an instance of our socks client, and we're gonna pass in the client, the mock client that we've created here, and then instead of returning hello, we're going to return some JSON that describes the eggs. So here I've just got it so that it will return 2 eggs with you know, the distance walked of 7 and 0 and the total distance of 10 and 2 and things like that. And now instead of making a request directly to our client, we'll make a request to our socks client and just get all the eggs, and that should be a list of eggs there. And we can make an assertion that, for example, the length of the egg list that gets returned is 2. So what should happen is our socks client will make a call to the URL with the eggs endpoint, and then this lot of JSON will be returned and parsed by the SOX client, and then ultimately that will return to us just as a list of eggs, and we can just, as a sanity check, just add an assertion that the number of eggs that's returned is 2. So if we give that a run, so we've successfully validated that our SOX client can handle a JSON response and return the parsed eggs correctly. And just to be a bit more thorough, we may as well add a whole bunch of assertions. So, for example, that the first egg has an ID of 1 and the other fields are also correct, and same for the second egg. If we just give that a run as well, we should hopefully validate that that's all good. And which it is. So I think that's probably a good place to stop. We didn't quite get to the implementing this walk button, but really that's going to be exactly the same as the getEggs method, but instead of get, it's going to be a post, and of course to a different endpoint, which I think we'll probably do in the next episode, where we're introduce some state management. So the goal will be to essentially move this interaction with the client. We'll move that to a separate class called a block or a qubit, and that will be responsible for handling events from the UI, for example, button presses, as well as piping data back to the UI to be displayed. So hopefully that sounds like fun, and thank you for watching. Cheers, bye.